Perfect. Okay, so next topic is Opportunities and Challenges, Part 2, by me, Joshua Hartshorne, Boston College. So I want to sort of continue this, this discussion of really what doing massive online experiments is for. And so here's some basic, and I actually want to start the other way, which is talk about in-lab experiments. So basic fact about in-lab experiments is the expected type 1 error rate is actually quite high. So using some sort of reasonable assumptions and looking just at the statistics, assuming that people have done everything correctly, Patchy and Harris estimated that around 2/3 of studies are probably false positives. And this, of course, is consistent with observation. To the extent that we know how many are false positives, that seems about right. Another well-known fact is that most of our subjects are North American undergraduates at prestigious research universities, which is obviously a very narrow slice of humanity, and a lot of what we learn turns out not to generalize to other demographics. There's also uncertain generalization to even slight design changes, and I'm sure you all have your favorite examples here, where running a study just slightly differently in ways that you didn't think would matter turned out to give you different results. Now, now, of course, running studies online, you can get a much larger range of subjects. So in principle, over half of the world's population is online. Now, of course, being online doesn't mean you can recruit them, but here's some evidence that you can recruit quite a bit. So this is a map of where subjects have come from for games with words over the last number of years. You can see decent numbers. Some of these, we have only a few subjects, like these African countries, like Egypt, only 2,000 subjects. I'll point out only 2,000, or some of these where we're looking at 28, is the size of a typical in-lab experiment. Now, if you look at this by city, that was by country. So in some places, there aren't enough subjects that, that Google aggregated by city, but you can see that, we're looking at people from a wide range of cities as well in decent numbers. Of course, you might worry, well, maybe this is just monkeys jumping on typewriters, or I guess these would be keyboards. But there's been a ton, this is obviously something lots of people have worried about, and I'm not going to go into the research because there's a ton of it at this point. And the take-home message from all of it is that data quality matches or exceeds that of in the lab if you use best practices, and maybe even if you don't. By best practices, I mean like having things like catch trials and manipulation checks and the things that you probably should do in the laboratory anyway. And this is particularly true if you're using volunteer subjects. So if you are paying your subjects, then of course they're, what they want, which is the money or course credit, if you're doing it in the laboratory, is different from what you want, which is good data. Whereas volunteer studies where subjects are not being paid, they're participating because they want to participate, not surprisingly produce very high quality data, because if they don't want to do the study, they just don't. And in retrospect, none of this is, again, there's a ton, there's probably been nothing as well studied in our field as these issues. So, so I don't think we need another review of it right now. I want to point out, this is something you basically already knew, which is that lots of important stuff happens on the internet, right? So people buy stuff, people learn things, they make encyclopedias, they do their banking, they pay their taxes, they do webinars. Clearly it's possible for people on the internet to follow instructions, pay attention, etc. And the only real issue is, can you get them to do that for your study? And that's going to be, have you set up the incentives right, or your spam filters sufficient? Same as for any other online activity. So in the remaining time, I want to talk about first, sort of picking up on a thread that, that Tom started, quantitative differences are qualitative. It's not just about statistical power. Obviously, going online can give us the statistical power and generalize to have meaningful replicability and generalize across populations. But it turns out that along the way, you get to do other cool things too. And then I'm going to finish with a little bit about major barriers and limitations to doing massive online studies. So my primary motivating example is going to be thinking about development and aging. So here's a sort of typical study of development and aging. I picked one of my own just so I'm not picking on other people, in which there are, as you can see, 3 different age groups, one of which is adult, which really obviously means undergraduate. Here's a meta-analysis that I did looking at a different thing in language, where we put together a bunch of different studies, which points out something pretty obvious, which is that most people are looking at the same narrow range of ages. So even when you put together data across a bunch of different developmental studies, you tend to get large areas missing, basically the entire school age years. You can't meta-analyze what was never tested. There were a few heroic efforts to try to look at a larger portion of the age span. So usually done in the context of norming IQ exams. Here on the left, this is from a really early relatively early IQ study, looking at a few different aspects of cognition. On the right is a more recent attempt by Salthouse that combined across, I think, a number of different studies he'd collected over the years. This is about 1,000 subjects. Oh, at the end dropped off of Doppelt and Wallace. That's again like a couple thousand, I think. Showing this, and both of these actually show this pattern of sort of an early decline in, let's call it fluid intelligence, and whereas you can continue to get better at crystallized intelligence through middle age. But again, there's only a handful of these studies. They've looked at really only a handful of abilities, and even though the data is quite coarse-grained, so you can see there's quite a lot of variability in the Salthouse graphs. So our knowledge is really patchy of development. We know a lot about, again, the very early years. We know something about college students, and we know something about retirees. Mostly we know about college students. And we just don't know very much about what's happening in between. So and it turned out one of the very first things people did with massive online studies back in really around the turn of the century, when people started getting large data sets from online experiments, was look at changes over age, because you get subjects of all ages. And what we're seeing is a remarkable amount of variability. So these are just some representative graphs. It doesn't look like this neat distinction between fluid and crystallized intelligence anymore. Here's sort of a summary schematic I tried to put together. These are, really drawn by hand, these lines, but sort of give you an idea of the range of different findings for different aspects of cognition. And we made the argument that, and I think this is right, that there doesn't seem that there's researchers often use phrase like healthy young adults, right? With the assumption that, particularly in developmental studies or aging studies, where the assumption is that college students are basically at their cognitive peak and everything. But it doesn't seem to be an age at which you're at your cognitive peak at everything, or even very many things. At almost every age through the lifespan, you're getting better at some things and worse at other things. So here's another study that goes into more detail. And I published a couple of years ago on critical periods in language. So critical periods in language are actually incredibly hard to study because the variables that you care about are, of course, the current age of somebody, the age at which they started learning the language, and their years of experience. All of these are going to affect how well someone's doing on a particular language at a particular time. So if we just take 2 people who started learning languages at different, say English, one started at 10 and one started at 20, but they're both 30 years old, they have the same age, but there's a confound of years of experience. The person who started at 10 has been learning longer. And because these are, I don't know what happened to the formatting here. It was all right yesterday. Anyway, these are linearly related. The current age is just the onset age plus years of experience. You can't experimentally deconfound them. So what we did, which was only possible because we were able to get huge numbers of subjects, was statistically deconfound them. So Here I have graphs of people starting to learn at different ages. Each of those lines there are different onset ages, years of experience. And we have monolinguals and immersion learners on the left. On the right, we have people who are non-immersion learners. These are people basically learn the language only in school as opposed to through immigration. And we tried to model how these various variables relate to each other. And I'm not going to go through the details of the math. You can look at the paper. But we're able to pull out an estimated rate of estimated learning rate graphs. This is the rate at which somebody is learning a new language based on their age, which again was something that just wasn't possible to measure before because it can't be measured directly. You can only work it out from, again, large amounts of data and some modeling. And we found something that really surprising, which is that it looks like you get worse at learning language in late adolescence, which is much later than anyone had guessed before, but all we had before were really guesses because, again, you just can't measure it through small amounts of data. Another example, again, where we're trying to dig into some phenomena in more detail and are able to do it because we have a lot of data, is birth order and vocabulary. So some years ago, actually one of my very first, it might actually be my very, no, it was not my very first online experiment, but was one of the earliest ones. We looked at actually marriages. So this, it turns out that people are more likely to marry other people of the same birth order, even when you control for family size, which has been a common problem in the birth order literature, is not controlling for family size. By the way, I guess I should say, so why does it matter to control for family size? The reason is that family size itself correlates with a whole lot of interesting demographic factors, right? So typically, larger families are more common of lower SES families, and being lower SES, particularly in America, makes it much more likely, for instance, that you will go to jail. So it turns out that being a middle child is correlated with going to jail, probably not because middle children are any more criminally inclined, but because they're more likely to be from a larger family, sort of by definition, and therefore more likely to be poor, and in America at least, therefore more likely to go to jail. So this is why pulling out family size ends up being really important, but is often difficult in normal size samples because you just don't have very many subjects. So controlling for family size is going to be very hard. So we had this study. There was one other study that had come out using constant data from the military in a Scandinavian country, looking at birth order, and you can see they pulled out size of sibship, so how many siblings, and you see a decline in IQ as a function of birth order. But there hadn't been very much else. And for whatever reason, I kept getting calls from reporters to ask about birth order. And I got tired of saying, I don't really know anything about birth order. Maybe people are more likely to marry people of the same birth order. And I decided might as well do a new study. So we had people do a vocabulary test and got birth order information from them. So here is family size 2 and vocabulary. And you can see across the sort of measurable lifespan, we see that the firstborn is doing better. This actually extends to younger ages, to down about 10 years old. I think it's pretty noisy at the younger and older ages, so I've cut them off of this graph. But you can actually find in a poster on my website the full graphs if you want them. We also see something similar for family size 3. So here again, the firstborn seem to have higher vocabulary across the lifespan. And this was a really exciting finding, in part because most of the work that's been, so there's been, as I said, so this like marriage stuff and IQ. But IQ, we're only looking at 17 and 18-year-olds because the large data sets that are available are only for conscripts in countries with mandatory military service. And so it wasn't clear if the birth order effects on intelligence last across the lifespan, or if there's something that dissipates soon after you leave your home. And many effects of the home do dissipate once you leave home. That doesn't seem to be the case for vocabulary. Now, we don't know, is this about vocabulary per se, or is it actually IQ? Vocabulary turns out to be, if you have only a short test, the best predictor of IQ turns out to be vocabulary, of all the various like subcomponents of IQ tests. So this could be an IQ effect. We don't know at this point. So those are from my own studies. I want to, though, again, really my goal here in this talk is to get you thinking about the kinds of studies that you haven't been running but could, and the kinds of questions that become much easier and more accessible once you move online, particularly if you have large data sets. So I'm going to go through two other examples in some detail that I particularly like. There are many, many other good examples. These are just ones that made for good slides. So this is a relatively recent study called Why'd I Have to End This Way? Understand the Consistency of Team Fracture. And I want to thank the authors for their slides for this. So the idea was, if we could rewind time, would troubled teams have the same outcomes? You know, sometimes teams just don't work together very well. Is that inevitable, or was it just like a bad experience? It could have gone differently. So their experimental method was to reconvene the same teams repeatedly without people in the team realizing it, and measure behavioral consistency across team interactions. So you have some people in a group, they interact, then they're all spread out into new groups, and then they are spread out into what turns out to be the same group again, right? So, but they don't know it because the identities are all masked from task to task. So they don't know that they're getting the same, sometimes working with the same people they had worked with before. And the question is the outcome of this experience going to be the same both times these groups work together? So if they had a bad experience the first time, does that happen again the second time they're together? And I'm sorry about the formatting. Seriously, it was right yesterday. I don't know what the deal is. Yeah, okay. So in round A, so the way they're going to mask it is everything's done through text. And so people have their, silly handles like conventional horse and fast frog. That's not the way they're going to be presented to each other. So conventional horse might say, "Hi there, little snake." But what mighty pony sees is, "Hi there, fast frog." Right? Because fast frog's actually a little snake, but conventional horse doesn't know that. The names are being switched programmatically. So people continue seeing their own name, but what somebody else's name is might be switched. So chat-based interaction, 140 teams of 3 to 4 people. This was run on Amazon Mechanical Turk, and there were 4 rounds of 10-minute tasks. And the question is, do we get consistency between 2 rounds of the same team? And they compared masked and unmasked conditions. So in unmasked, you're working with the same people again. And the way they measured basically did people did the group work well, was you had the option to say you didn't want to work with a particular person again. And that was sort of the measure. If people are all blocking each other, then apparently that group didn't work well together. And the result was, it depends on what task they were doing. You'd have to go look at the paper if you want to know. Because what I'm interested in here are not the results, but this is the kind of experiment that would be it's a very obvious thing to work on, right? To try to sort of replay history, and very, very hard to do in the laboratory. Think about how you would do this masking in a laboratory setting. It's something that's really only feasible online, but immediately becomes quite feasible online. And hopefully you can see, a wide range of applications this sort of setup could be applied towards. One that because as a language researcher, I'm really interested in is convergence in conversations. So we know that as people work together, they tend to converge on similar vocabulary, similar syntax. They start talking similar ways to each other. And again, you can see how this sort of setup would be a really interesting way of seeing to what degree was that a function of the inherent biases of each of the individual speakers in a group, and how much of it was just random chance. could have gone down one direction, but went down a different. Another one along these lines, this is one of the oldest sort of really exciting massive, well, it wasn't that massive, but online studies. I saw this, I think, early in graduate school, and the study was really influential in the direction of my research, even though I do nothing like this, but just in thinking about what kinds of things could we do online. The basic question is, was Justin Bieber a hit in all possible worlds, right? You might be of the opinion that Justin Bieber's music is so awesome, of course he would have been a huge hit. My opinion might be this was a matter of random chance. A few people, for whatever reason, liked him and started some sort of social media spiral and became popular for that reason. So here's what Selganic and colleagues did, which is they set up a music download site. And these all used music from obscure indie bands, so people would know about them, and they could just go to the website and download music. But they were randomly assigned to one of several possible worlds. One possible world, they had no information about what other people were downloading, right? So, and we're going to call this the independent world, and hopefully it gives an indication of what the sort of the independent of what other people think, what the actual quality of the music is. But then they could be assigned to one of a number, other people be assigned to one of a number of worlds in which they're going to see what other people have downloaded. And this wasn't manipulated, it's just allowed to build the way any download site would, right? So you're just seeing what people downloaded, and there's going to be some variation across worlds, just because different people download different things. All right, so we're gonna have on the y-axis, in these worlds, how popular was something. On the x-axis is how popular it was when you didn't know what other people liked. There's obviously a correlation, but if you look at the extremes, it's pretty clear. Stuff that was good is just good. Stuff that is bad is just bad. Things that you would of your own accord download, even if you didn't know what other people were doing, tend to get downloaded a lot. But in the middle, this vast middle, it's pretty random. There is basically no relationship for those inner two quartiles between how popular music was if you didn't know what other people were listening to, and how popular it was if you did know what other people were listening to. Again, in these random worlds where you have different groups of people doing listening. So those are hopefully some motivating examples for the sort of qualitative difference, the kinds of studies that you could do online that just are not feasible in the lab. And of course, that's looking just at web-based studies. We haven't talked about studies involving people using Fitbits or virtual reality. And yes, there have been massive online virtual reality studies, or at least there's been one that I know of, people using their mobile apps on phones. There's been some very cool studies doing that, and so on. So I want to conclude very quickly with some major barriers and limitations to running online studies, especially these sort of qualitatively different massive online studies. One is, of course, not everybody is online, right? So if you want to work with hunter-gatherers, then you probably can't do that study online. There's going to be some other populations also. Half the world is online, but half the world is not. Also, some technology is just unavailable. There's no home fMRI. If you want to do fMRI, you probably have to bring people in. For EEG, it's less clear. There are commercial EEG sets. None of them are particularly popular yet. They're meant to be used with like game consoles or education apps. If they ever take off, it may start being possible to do massive online EEG studies. I think the biggest issue is the weight of 150 years of history. So our paradigms, and this is again continuing a thread that Tom was talking about, our paradigms for running studies are really based on that old model of the in-lab study, and they're optimized for the in-lab study. You can't be optimized for two different things simultaneously. They are often unoptimized, anti-optimized for running online. And I think one of the biggest problems I know that I personally have faced in trying to do online studies is rethinking what kinds of paradigms that I want to use, to think of something that would actually work well online and get those large numbers of subjects. The other thing is that amateur subjects behave unexpectedly. One of my favorite examples is, so we're used to testing college students who are semi-pro test takers, and our experimental paradigms are really based on tests, right? They generally look like school exams. But of course, in the wider world, most people don't go to college. They're not necessarily elite test takers. And so they can do weird things that you're not expecting. So a friend of mine was just norming a digit span task, right? Where you are given a series of numbers and you have to repeat them back. And so my friend read the numbers, and the person she was norming it with, who was not well educated, wrote the numbers down and then read them back. And when the experimenter said, "Wait, so you can't write down the numbers, you're supposed to remember them," the subject said, "Why are you changing the rules on me? You didn't say you couldn't write them down. You wanted me to tell them back to you, and this is going to be much better if I write them down first, obviously." When you think about it, that's a perfectly reasonable response. The subject just didn't have the cultural knowledge that we expect our subjects to have. And the other thing, and I think this is something that is hard about, especially doing the massive online studies, is that you need to make sure that your instructions and really that your paradigms are such that people will understand what it is you are asking them to do without being elite test takers. They may also, I'm going to breeze through this, they may talk about the study. So this is actually not when we hit the top of Reddit, which we've done sometimes for some studies. This is a more recent one, but people post the results from an experiment. That's sort of fine. In this case, people are actually pretty good about not talking about what was going on in the study. That didn't happen in this more recent one, Test Your Musical IQ, where people actually made videos on YouTube of themselves doing the experiment and talking about it. And you can see those got a lot of views. Here's this one in particular. I don't know who these people are, but they have 2.5 million subscribers. So I imagine their videos are really good. Anyway, that is something that it turns out we had designed this particular study that we can deal with the fact that some people are non-naive to our stimuli or to some stimuli. We'd actually had randomized stimulus sets. But this is something that in general, if you're going to do massive online studies, you need to do a lot of piloting, observe what your subjects are doing, ask them, get feedback, and plan for what happens if they do weird things like tell each other about what's going on in the study. By the way, I would not assume that that is not happening when you run studies in the lab. I think that a lot of your subjects probably are talking to each other about the study. You just don't know about it. We're able to know about it when it's online, which is actually kind of nice. And on the whole, I would rather have these problems than these problems. And did I have anything? Nope, that's the end of my show. So if I can figure out where my mouse went, I will go back to the meeting. There we go, stop share. Okay, so, and I have a question from Mark.
Hi, can you hear me?
Yep.
All right, so I really enjoyed that talk, and I'm kind of thinking a lot about the latter points about concerns. What comes to mind, I think, as sort of like an umbrella phrase that's different about an in-lab experiment and online is in lab, I think there's a good deal of good faith behavior on part of the participant. There's by design, or sort of self-selection, in that the students and myself sort of agree about the value and merit of experimental work and that sort, that's one possibility. But I think the broader problem is just when I'm in front of my computer, I'm my own boss, so to speak. And whatever comes on my computer screen, I get to decide how much I'm going to engage and how much I'm going to be an honest participant in. And so how do you handle that possibility? And what are your thoughts in general about it?
So I think a couple of thoughts. First, I think that people probably overestimate how much their subjects are in the laboratory are actually good faith engaged, and underestimate how much they are online. So when we and other people have done direct comparisons of online and in-lab studies, you sometimes find, better paying attention in the laboratory, particularly for if you're paying subjects, but sometimes not. I think on the balance, people tend to find that the online subjects are paying more, at least as much or if not more attention. But I think, beyond that, this is actually part of why I prefer not doing studies where you're basically where the incentive is unrelated to data quality, right? Where what people really want is, you've told them they have to do this experiment in order to get to get an A in your class, and so they're doing the experiment to get an A in your class, not because they care about the experiment necessarily that much. As opposed to, again, people provide phenomenally good data to, say, Minecraft, because they're really into Minecraft if they're playing. And I think that's important online, but I think it's actually something that we probably should be doing more of in the laboratory, paying more attention to actually having engaging experiments that people really want to do and want to do well in. Beyond that, though, I think there's a ton of methods that have been developed over the years for checking to make sure people are paying attention, doing things to make it just annoying to be not paying attention. So if you have the opportunity, have this kind of study where you can give people feedback on trials, like they got it correct or incorrect, give them a very, very long, annoying beep when they get something wrong, and people will very quickly discover that it takes less, they'll get done sooner if they get questions right. Anyway, so we're going to need to move on to the next talk.